The term hacker comes from if they developed a piece of code that was like interesting or original or clever solution that was called a hack. So these guys would start to call themselves hackers. It starts at MIT with the first computer arriving on campus, basically. And a group of boys, they were all boys at first, they get very fascinated by this machine and they start to develop sort of a vision and a mission for software in general. They see it as something that's going to change the world and they want to get good at it and they want to use their power for good in a way. And at some point they decide to take their product commercial. First they want to do that together. They want to found the company together, but it quickly turned out that they sort of have different visions. So one of them really believed in the hacker ethos, sharing information, sharing code, working collaboratively, while the other, he wanted to take a more commercial approach. And at some point they decide to separate ways and they found their own companies. To make matters worse, Nofsker with his commercial approach then decides to hire a lot of the MIT lab's hackers. So the people that were working on this software, they're now hired and they are banned from sharing their code at MIT. So it hollowed out the AI lab and Stallman was left kind of devastated. Like his little paradise on Earth was ripped apart, hollowed out, the AI lab was sort of done. Now for a while, Stallman would look at the documentation, look at what they developed, and then he would redo it himself. That in itself is pretty incredible. The guy was single-handedly doing the work of an entire company just to sort of make a point. But he figured that for the longer term, this was not a very plausible approach. So that's when he developed the vision for free software. And with that, he introduced this collaborative approach to software programming. So it wasn't this top-down thing, but it was like anyone could check the software and improve it in that way.
Welcome back. I'm here with Aaron Den Weerdem, and we are going to discuss the next episode of this podcast series. And it's going to be about free and open source software. Previously, we talked about economic theory. We've talked about money, and today we're going to talk about some of the computer science and some of the technologies that enable the creation of Bitcoin and what led up to the creation of Bitcoin in his book, The Genesis Book. Welcome, Aaron.
Yeah, thanks.
First up, in your book, you talk about this hacker subculture and the hacker culture. Let's start there.
Yeah, so this part of the story starts in the 60s, basically. Mm-hmm. It starts at MIT, the technical university, and it starts with the first computer arriving on campus, basically. So the first computer arrives on campus, it's this big machine, fills a room, and a group of boys, they were all boys at first, they get very fascinated by this machine. They were part of the miniature train railroad club. But they weren't interested in trains themselves so much. They were more interested in like the getting the tracks to run and figuring out all the switches and the flips and the stuff that makes it work. But now this computer arrives on university and they realize there's a bigger game in town. So they get very interested in this computer, right? And they start to work on this computer also at night, because at night it's available. Like during the day, university professors and other students are also using it, but at night it's all theirs. So at night they gather around this computer and they learn themselves, they teach themselves to program on it. Now, because it's only one machine, they share this machine and they share essentially the programs on this machine. So it's this very collaborative effort. They program software and they help each other with that, and it becomes sort of competitive, sort of collaborative, and a subculture emerges around it where they're very passionate about this, and they start to develop sort of a vision and a mission for software in general. They see it as something that's going to change the world, and they want to get good at it, and they want to use their power, for good in a way. So the important thing is that it's this open, collaborative process where they all, work together on this one machine and help each other So the term hacker comes from if they developed a piece of code that was like particularly good, or they tried to solve some sort of problem, and they came up with a particularly interesting or original or clever solution that was called a hack. So these guys would start to call themselves hackers. So that's where the term comes from, and that's where the hacker subculture starts to emerge.
Very interesting. Let's talk a little bit about Stallman. What was his role in this process? Who was he?
Yeah, so Stallman was one of these hackers. He joined a bit later, of course. Like the subculture established itself at the university at MIT, and they share this philosophy about collaborative hacking and sharing information. Like information should be free. They have this ideal that information should be free indeed. Stallman. He actually went to a different university in the same, also in Cambridge, Harvard, I believe he went to. Yeah. But at one point, he decides to visit MIT's AI lab. So the AI lab, that is the computing environment at MIT. That's where this computer exists. And he heard about it. He heard that there was a particularly powerful computer at this university at MIT. So he decides to visit MIT one day to ask for documentation for the computer. He's just interested. For context, this is a guy that's, even before he went to MIT, he was super fascinated by computers. He learned himself to program before he even had access to a computer. Wow. He was just going through the computer manuals and sort of learning how these things work and studying it, and very passionate about it. So he has a job or he has a summer job at IBM at some point, where he's tasked with coding up. I don't know what the exact job was exactly. It's in the Genesis book. It's slipping my mind, but he was tasked with some sort of job. He had all summer for it. He finished it in like a week, and then the rest of the summer he just spent at IBM. Yeah, just playing around with it, developing a word processor, I believe, text processor. Not Word, by the way. So Windows. That's a Windows program, but the text processor. Anyways, he ends up at Harvard, continues to work on computer science, and one day decides to visit MIT, and he asks for documentation. The people at MIT say, "Yeah, we don't have documentation," but the fact that you are someone who comes to our university to ask about documentation, to ask about this computer, you're the type of guy we like. We're the type of guy we want here. So he gets hired. He gets hired and at MIT's AI lab. And there, what he finds is, he finds sort of a mini paradise for him. Because at Harvard and at IBM, computers, the computers they had there were actually designed in the access to the computer had sort of hierarchical limits. So there were some people in charge of this computer, and they would decide what other people would get to do on the computer and what they were not allowed to do. While at MIT, they had this open hacker ethos where the computer was just a shared resource, anyone could use it. Yeah. So he gets at MIT, he gets hired there, and for the next decade, he finds himself truly at home, and he finds a form of fruitful anarchy, basically. Yeah. Like it's an anarchy. There are no rules. Anyone can just work on the computer, do with it what they want, share their resources. People help each other, and that's how they start developing software over there.
I'm going to read a couple quotes by him. Users of our system were free men, asked to behave responsibly. Instead of an elite of power, we had an elite of knowledge composed of whoever was motivated to learn. Since nobody could dominate others on our machine, the lab ran as an anarchy. The visible success of this converted me to anarchism. To most people, anarchy means wasteful, destructive disorder. But to an anarchist like me, it means voluntary organization as needed, with emphasis on goals, not rules, and no insistence on uniformity for uniformity's sake. I love that. That was one of my favorite quotes in the book.
Right. Yeah. So, he finds himself totally at home there. But at some point, the AI lab kind of gets ripped apart. This is because two people at the MIA lab, one of them was called Novsker, and one of them...
Greenblatt.
Thank you. Yeah, they are developing AI tools, early AI tools, and you should think, early AI tools. Think of like chess computers and that kind of stuff. And they build special software for that. And at some point, they decide to take their product commercial. First, they want to do that together. They want to found the company together, but it quickly turned out that they sort of have different visions. So one of them really believed in the hacker ethos, sharing information, sharing code, working collaboratively, while the other, that was Navsker is the other. Greenblatt wanted to stick to the hacker ethos. Navsker, he wanted to take a more commercial approach. So he wanted to license the software.
Copyright licenses.
Yes, exactly.
Stuff, yeah.
So this caused a rift. The reason he wanted that, in part, was because that's the way to get investors in the company.
Yeah.
And that's how you make a commercially viable product. But the two men could not agree on this. And at some point, they decide to separate ways. They go their own way, and they found their own companies. So now there's two companies kind of doing the same thing. One of them has more of the hacker ethos. One of them has a more commercial approach. To make matters worse, Navsker, with his commercial approach, then decides to hire a lot of the MIT lab's hackers. So the people that were working on this software, they're now hired, and they are banned from sharing their code at MIT, at the AI lab. So it really prevented this. It prevented the other company, Greenblatt's company, from sharing the code and working collaboratively, because all the hackers were gone, all the talent was gone, and the software that they developed was proprietary.
Proprietary software.
Yes, exactly. So it hollowed out the AI lab, and Stallman was left kind of devastated. Like, his little paradise on Earth was ripped apart, hollowed out, and he didn't. The AI lab was sort of done. Now, for a while, Stallman sort of took up his put on his activist hat, and he started to redo the work that Navsker and his company were doing. So Navsker was building this AI tool at his company, and then Stallman would look at the documentation, look at what they developed, and then he would redo it himself.
Yeah.
So this was a company that hired like 6 developers from the AI lab, and then Stallman on his own would just copy their work and share it publicly, share it with Greenblatt, and made sure that Greenblatt's company could continue operating. So that in itself is pretty incredible. Like, the guy was single-handedly doing the work of an entire company just to sort of make a point. But he figured that for the longer term, this was not a very plausible approach. So that's when he developed the vision for free software. So free software it was meant to counter the trend of proprietary software. So proprietary software is closed software. And licensed and all of that. Maybe I should give a little bit of context what that means. So what that means is, so when developers write code, they write source code, right? There's different programming languages that they can write in, and that programming language can be written and read by humans. So humans, can see what a program is doing. But a computer can't read this. So for a computer to run a program, it has to be converted into ones and zeros. So you write source code, and then that's converted into ones and zeros, which a computer can read. So when you run a computer is just reading the ones and zeros, and then running the software, running the program. But a human cannot read the ones and zeros. For a human to know what a program is doing, you need the source code. So when proprietary software became a thing, the commercial software, you basically bought the ones and zeros, and you ran that, and then you ran the program. But then you don't know what it's actually doing. You know a little bit what it's doing because you see on your computer screen what's happening, but you don't know exactly what it's doing. It might be doing other things in the background. It might be spying on you. It might be...
Which is happening today at large scale with a lot of these programs everybody runs, right?
It might be collecting your data. It might be doing things that you don't want it to do, and you wouldn't know it. So Stallman had a big problem with this. He saw this as a power relationship. So it was a power relationship between programmers and users, because users really had to trust the programmer. The programmer said, here you have a program, it does this and that, and then the users would just kind of have to take the programmer's word for it.
I actually highlighted some of his quotes here. He said, "If the users don't control the program controls the users. With proprietary software, there is always some entity, the owner of the program, that controls the program, and through it exercises power over its users." Stallman instead wanted computers to be tools of empowerment and freedom. He believed that users should at all times be in control of their own machines.
Yes. So he came up with the idea of free software. So to counter the trend of proprietary software, he came up with the idea of free software. The basic idea behind free software is that you need to publish the source code. So you publish the source code, you publish the program, and now everyone can actually read the source code and check that the source code really does what the programmer says it does. So it takes away that power from the programmer. Users no longer trust the programmer. Now, specifically, there's a couple more things that free software did or what it had to do. So this is called the 4 freedoms. So you have it open in front of you, right? Yeah. So maybe you can read the 4 freedoms.
So this is almost a little manifesto. It says, the freedom to run the program as you wish for any purpose, freedom 0. The freedom to study how the program works and change it so it does your computing as you wish, freedom 1. Access to the source code is a precondition for this. The freedom to redistribute copies so you can help others, freedom 2. The freedom to distribute copies of your modified versions to others, freedom 3. By doing this, you can give the whole community a chance to benefit from your changes. Access to the source code is a precondition for this. And then in short here, and I highlighted this as well, the freedom to run, copy, distribute, study, change, and improve the software, which is the essence of free software. And then I'm going to ask you a question because I love this little statement. He says, with free as in freedom, the hacker liked to emphasize, not as in free beer. I have my own thoughts on that, but can you expound on that and explain what he meant by that?
Yeah, so it really introduced the hacker ethic, basically, right? So the hacker ethic that emerged at MIT, he now sort of formalized that as a way forward for software, for computer programming. So indeed, you publish the source code, then anyone can use it as they want. Anyone can check what it is, that it does what it's supposed to do. So the programmer doesn't anymore have the power over the user. And then anyone can also edit it, change it. You know, if you have software but you want it to work a bit different for some reason, you can just change the software. You can change the source code, fork it, if you will. And then you can also distribute that change. So it embodied a philosophy for hackers, for software programmers, for computers in general. And he started to realize that vision. So one of the things Stallman at first decided to do himself was he was going to create an operating system that was completely built out of free software. So that's important because if you, let's say you have a text editor and the text editor is free software. So now you don't have to trust the programmer of that software. You know exactly what your text editor is doing and what it's not doing. But if you have to run that on a closed source proprietary operating system, well, then you still don't know what your computer is doing.
Yeah.
So his point was really to realize this vision. Your computer from bottom to top needs to be free software. It needs to only include free software. That's the only way you know for sure that your computer is doing what you want it to be doing and nothing else. Mm-hmm. So he founded the Free Software Foundation, and he started to build this operating system called GNU, GNU. And eventually, which I want to point out, that's no easy task. That was a big project.
Oh yeah,
it was kind of unbelievable.
Yeah, no doubt. This is like the base of the pyramid, right? The foundation that it sits on. We have to redesign everything from that foundation. And to his credit, today all of the operating systems that we use, right, Microsoft, whatever, who knows what they're doing? I mean, even if you look at the processes and the systems and processes, it's constantly sending information about what you're doing. I think I saw something like recently that they want to do this AI snapshot thing that just without basically, I don't think you even get to opt into it or you get a choice about it, but it just monitors every single thing you're doing, and then it can have flashbacks of what you did. But I know from looking at the Windows processes that there's constant communication, and I'm sure this goes on with Apple and any other kind of Mac OS, whatever. There's constant communication with servers and stuff, and you don't really know what's happening under the hood, right?
Right, exactly. So yeah, he set out to create a free software version of an operating system called GNU. That stands for GNU, it's not Unix. So it's like a recursive acronym. It's kind of funny. I
That's
think
kind of funny.
like
But yeah.
like if GNU stands for GNU's not Unix, then what does GNU stands for, anyways? Yeah, so he created that, and with that he introduced this collaborative approach to software programming. So it wasn't anymore. It wasn't this top-down thing, but it was like anyone could check the software and improve it in that way.
Mm-hmm. And I think that brings us to probably my favorite part of the chapter, which is the discussion of this concept, and might even, I think it's an essay as well, but this idea of the cathedral and the bazaar.
Yeah. So one thing to quickly mention as well, or I'll just continue riffing here a bit.
Yeah, continue riffing.
So there was GNU. So Richard Stallman developed GNU, and then ultimately it was Linus Torvalds who added the Linux kernel to that. So with the Linux kernel, that was sort of the last missing piece of the puzzle. That created the Linux operating system. So now you truly had a free and open source software operating system called Linux. I think Stallman is a little bit unhappy with that because it was like all GNU, and then last second, Linus Torvalds swaps in and he creates the kernel, and now it's called Linux. So he calls it Linux GNU, Linux/GNU, or maybe even GNU/Linux. I'm not sure which one it was. But he wants to emphasize that no, guys, most of it is actually GNU, which is fair. Most of it is GNU.
He's not wrong.
He's not wrong. But the important thing is that it worked. So now there was actually an operating system called Linux or Linux GNU that was entirely free and open source software. So and nowadays GNU or Linux is very popular. Of course, it is actually used by a lot of web services. For example, web servers. Like it really took hold. Now, what's interesting is that Stallman, he created this sort of with an ideological, from an ideological perspective, right? He had an ideological reason, free software, indeed, as in freedom. Like he wanted to take away the power from developers and give it to users. As it turned out, however, it also resulted in high quality software. The reason for that, and this is where we get into the cathedral versus bazaar essay.
So let me read this from your book.
Yeah.
You said, but Torvalds' main innovation arguably wasn't the Linux kernel itself. It was how he produced it. Over the years, the software engineer developed a process explicitly designed to collaborate over the internet.
Right.
And that's where I think Eric Raymond here wrote in 1997 the essay, The Cathedral and the Bazaar.
Yeah. So indeed, Eric Raymond was a Linux contributor, and he at one point wrote the essay, the Bazaar, the Cathedral and the Bazaar, and in it he basically described two forms of software development. One form was that's more what was used at the AI lab, for example, is you got this group of expert programmers, and they would meticulously go over the code, write the code, review the code, go over the code, because they knew the source code is going to be published. So if there's any bugs in it, anyone can find these bugs. So they were very careful about preventing bugs. Like they had this kind of top-down approach. Like they were the experts. They were going to be very careful to make sure there weren't any bugs. And only when they were very sure there wasn't going to be any bugs in the software would they release it. However, with Linus Torvalds, he sort of flipped that upside down. He had a process that was more out in the open. So developments actually happened more out in the open. And then there were more software releases. So some of these software releases did contain bugs sometimes, but also because development happened in the open, these bugs were also spotted earlier. There were a lot of contributors to some of these projects that were all sort of keeping an eye on the development of them and reviewing it and writing it and improving it. And then if a bug slipped in, it would be released, but it would also be fixed much quicker.
Yeah.
So it's sort of this this comparison between, are you going to have slow releases that are very well vetted, or are you going to have faster releases, but that are also faster fixed if there's an issue? Now, it turned out that this led to very high quality code. So the actual, some examples of free and open source software may be good to mention are indeed Linux, but nowadays also Firefox Store. It actually led to very high quality software.
Yeah.
Which was sort of
unexpected.
Yeah, sort of surprising, right? Like you would think if you pay someone a lot of money, if you pay a company or you pay, or if a couple of experts do it, that would probably be the way to do. But it turned out that having it developed out in the open and letting anyone contribute actually worked really well. It led to really high quality software.
So I didn't know any of this until I read your book. So this to me was like a really interesting chapter because I hadn't studied or heard about that. Like this idea of, and I think it's called Linus's law. Linus's law. Yeah. I mean, very, very cool. I'll read it out.
Go for it.
Given a large enough beta tester and co-developer base, almost every problem will be characterized quickly and the fix obvious to someone, Raymond wrote in his essay, summing up one of the key lessons he learned over the years, or less formally, given enough eyeballs, all bugs are shallow. I love that. It's almost like there's another quote that we use, I hear at a quote I really love, which is sunlight is the best disinfectant, right?
Right.
And we use that for politics and all sorts of things, but it carries over and it's so true even for, shipping code.
Yeah, it's sort of a similar philosophy. Yeah, that's right. His point was less ideological. Like his argument was more pragmatic for free and open source software, or free software as it's still called at this time. So he thought, the freedom thing is nice and important, and but it's interesting that it also leads to high quality code. So if you are a company, it actually also makes sense. Like even if you don't care about these ideals, even if you don't care about this freedom argument, even if you don't care about developers having power over users, even if you don't care about that, it's still a good idea to use free software or to make your free software. Well, so that's why he was one of the people that led the rebrand to open source. To sort of emphasize that it's not just about freedom, it's also just pragmatic. It's useful if you just want to run a company. So they rebranded it. There was an effort to rebrand this
free software to open source software.
Yes. Now Stallman didn't like that.
Stallman wasn't happy about it.
Yeah, Stallman for Stallman specifically, it was about freedom. Like he was ideologically driven, so he didn't like this rebrand. So since then, both terms are used sometimes. Sometimes it's called free software. Sometimes it's used open source software. In a practical sense, it's basically the same thing. There might be some nuanced differences of like with the full freedoms, maybe because the open source community has its own like for freedoms.
Like you can take something open source, build on it, and then if you wanted to do a company, you can make it closed source later.
Whereas exactly.
With Stallman's idea, he kind of said, "Hey, anything you build with this, you have to keep it open source. It's kind of like..."
Yeah, that was the specific license he developed around it. So Stallman indeed, he developed a license that said free software, you can copy it and you can reuse it, but you can't make it closed source.
Exactly, okay.
Like if you do copy it, then whatever software you are building needs to also be free software. And with the open source guys, they had a more pragmatic approach. They said, this is for quality purposes. That's the big benefit. And, if you want to take it and then close source it, that's also okay. So that's a different type of license they developed.
But I do like trying to bring it all together to widen the tent with the branding of free and open source software. I think that just not only does it encapsulate the ethos of freedom and the hacker subculture and all these ideas, but it also brings in this cathedral bazaar idea or essay and the implications of that, which say, this is a better model, not just because of these concepts, but it just works better, right?
Right. Yeah. So sometimes the term free and open source is used to sort of take both sides of the ideological divide in that sense and sort of say, hey, it's just about, or it's pragmatically what we're doing, but also free. Whoever is using the term just is sort of inclusive. It's sort of including both. That's the term free and open source software. That's why I called the chapter free and open source software. So the reason this is a chapter in the book, maybe it's good to get to that point. Or, well, one thing that's interesting to mention, which I also get into in the Genesis book, is so Raymond, he described, this idea of with enough eyeballs, all bugs are shallow, so Linus's law. So what this means, if you have a software project that is open, let's just call it open source for now. It's such a mouthful to say free and open source software every time, and open source is the one that caught on a bit more. Anyways, and we're talking about Raymond in this context. So I'll use the term open source for this minute. So if you are developing open source software, then you do need these contributors.
Yeah.
Now, how do you get contributors in an open source software project? You could pay them, but there's usually not a lot of money involved in open source software development. But you definitely can't force anyone. You can't force anyone to help. So the real path forward here is to give developers a reason to contribute. So what could be reasons to contribute? Well, it needs to maybe solve a problem that these developers themselves have, or it needs to align with their personal values, or maybe these developers want to sort of, practice their skills or showcase their skills, or whatever the reason is.
Here in my notes I have, Bazaar needs consensus. So this idea of consensus, right? It needs people to be sort of aligned or have some reason to want to be involved.
Yeah, I don't know if I would use the word consensus. I would say goal alignment.
Goal, I mean, yeah.
Yes. People need to have a shared goal for the software. People need to you need to give developers a reason to want to build this software.
Yeah.
So what that means in turn is if you have a company and you want to take it in one direction, but your employees have a different vision, well, bad luck, bad luck for the employers, basically, because you're paying them and you can tell them what to do.
Yeah.
Right? The CEO of a company can just say, this is where we're going. And if you don't like it, I'm going to hire another developer.
Yeah.
With open source software, you cannot do that. So what comes in instead, the dynamic that you see with open source development, is it's much more collaborative. The developers are themselves sort of in charge. So it's bottom up again. So we discussed the difference between top down and bottom up in economics, right? Earlier in another episode. But here you see it in software development as well. That free and open source software development has this bottom up approach. It needs it needs voluntary contributors that themselves believe in a goal. So therefore, it's really the contributors that are in charge of the project rather than the lead developer, so to say. If the lead developer says we're going to go there, and the programmers, the open source contributors, they say no, we want to go there. Well, they can just copy the code and go wherever they want to go. So
it's a bottom up approach as opposed to a top down. That's kind of why I guess I'm biased to use the word consensus because it's in my company.
Of course,
in my mind, I'm thinking you need the consensus of the community to do these things.
Right. Yeah. So it's a nice tie-in, I find, with the first chapter of the book with the spontaneous order, is that open source software development is also a spontaneous order. And indeed, Raymond actually uses that term. He compares it to a free market. Like, I love that. Yeah, bottom-up software development is similar in that sense. It's all a spontaneous order.
I love that. Let's close out this episode.
Well, do you want to tie it in with Bitcoin for a second?
Sure. Yeah, I guess we can.
Yeah. So why is this all relevant to Bitcoin? Well, it's very relevant to Bitcoin because Bitcoin, of course, is a trustless system. Like Bitcoin has a 21 million limit, for example. And if you own Bitcoin, then no one can take it from you. Now, how do you know that's true? Because you can review the code. You can actually look at the source code and see what it does. You don't have to trust Satoshi Nakamoto. You don't have to trust the developers of the system. You can, if you can read programming language, yourself read that code. And even if you can't read programming language, other people can, or maybe you know someone who can. In either case, the whole world is watching at this code. So you know you don't have to trust like a single body with that code. That's fundamental for Bitcoin, right? Like if Bitcoin was run like a company, it would be completely different.
Absolutely.
But Bitcoin is trustless. And one of the big reasons it's trustless is because the source code is open. And then as well, of course, it's very important that Bitcoin is high quality code. We need to make sure that there's no bugs in it. So the best way to make sure that there's no bugs in it, as at least according to Linus's law, is to let everyone review the code and let everyone review fixes. And then you have this concept, there's no one in charge of Bitcoin. Bitcoin is really developed by its body of contributors, and no one can tell them what to do. Like it's this bottom-up concept in that sense.
And the interesting thing about this is if, I don't know, I've read through tons of conversations on the Bitcoin Talk forum and reading all the conversations between people. And this idea, this approach of, given enough eyeballs, all bugs are shallow. It played out multiple times in Bitcoin's original, like OG history, right? There were bugs identified. There were things, patches that were shipped by this concept, right? So I do find it fascinating that Satoshi chose this bizarre model to develop this.
Yeah, I mean, since Satoshi released Bitcoin, of course, under MIT's open source license, if I'm not mistaken. In any case, he released it as free and open source software. And at some point, he even stepped down himself. He's gone. And now the project is really carried by these open source contributors that, over the years continue to improve the code. To this day, there's still, 2 new Bitcoin core releases each year. And each version is basically better than the previous one. Not just because it has new features, which it obviously not often doesn't, but because bugs are fixed, the performance is improved in other ways. Yeah. It gets better and better and better, and that is in large part because Satoshi released it and put it in the world as this free and open source project that can be improved over time.
Any Bitcoin core dev that I've ever come across or spoken to, they're largely in it for the ethos. They believe in vision, right? There's this consensus of, hey, this is a powerful tool. They're not doing it simply just for money, right? What are your thoughts about, and I know this has been somewhat of a controversy recently within the community, certain companies paying open source developers, whether we call them donations or, whatever that might be. What do you think about all that?
Yeah, I mean, so as long as there are enough developers they're all checking each other's work, right? So if a developer proposes something, every other developer is going to look at that proposal, and a number of them need to actually approve it before it can get in, or at least that's the culture that they use for development. Like it's not the case that one developer can just put stuff in the code. No, they have to all review it, all sort of sign off to it. I mean, not all of them, but it's sort of an organic process where at least a good number of them must have looked at it and vetted it before it makes it into the software. So maybe in a world where like one company is funding it all, that would get a bit iffy. But right now, if there's a company that's funding 1, 2, 3 developers out of dozens, then I don't think it's really a problem. It is still something that developers can and should take into account. Like if a developer proposes some feature and that it happens to benefit the company it's working for, like that, that might raise suspicion. Yeah. But I think ideally, actually, even that wouldn't matter. Like ideally, you would just look at the proposal itself.
If it makes sense,
is this good for Bitcoin or not? Exactly. Yeah. Regardless of who's funding a developer. Like, and I think to a large extent that is the case now.
I agree with your take completely. Yeah. I think as long as it's out in the open, sunlight is the best disinfectant.
Yeah, exactly. So that is how Bitcoin is being developed, and I mean, so far so good in any case.
So I'm gonna end this by repeating what you said earlier, because I think it's a really cool idea to think about. And that idea is that this free and open source software is essentially particularly open source software is spontaneous order for these projects and for code, right? Is that how you would encapsulate that idea?
Yeah, that's it. I mean, that's sort of the conclusion of this chapter in the Genesis book.
I love that.
That like a free market, a free and open source project is also a spontaneous order.
So as you have it quoted here at the end of the book, it's the Linux world behaves in many aspects like a free market or an ecology, a collection of selfish agents attempting to maximize utility, which in the process produces a self-correcting spontaneous order more elaborate and efficient than any amount of central planning could have achieved.